Hello students, welcome back to another video. Today's video is going to focus on these two devices, motors and generators. I'm going to compare and contrast these two things, and they both operate off of the process of induction, which we talked about in the last video. So if you don't remember, induction is the process where a change in an electric field can induce a magnetic field, or a change in a magnetic field can induce an electric field. First, I'm just going to write out what these two things do. Okay, so here I've written out the functions of both motors and generators. Motors convert electrical energy into mechanical energy. So they start with electrical and end up with mechanical. Generators do the opposite. They convert mechanical energy into electrical energy. In order to explain how these things work, I'm going to have to draw a diagram for each one, and then I'll elaborate on how these devices accomplish those energy conversions. Here's a very simple diagram of a motor. I'm going to explain what's going on here because my drawings are not amazing, but it starts off with electrical energy coming from some source of energy. In this case I drew a battery. Current flows from the battery into something called a commutator and a brush, and then from here it moves in through a loop which is surrounded by a magnet. Here I've drawn the north and the south pole. So there's a magnetic field going from the north to the south pole. Okay, so here I've drawn that in green ink. Okay, as the current runs through this loop and passes through this magnetic field, this all results in a magnetic force that is applied to this loop, which causes it to rotate around. This mechanical energy can then be harnessed on the other side of the diagram. So we started with electrical energy, and because of induction and the changing electric field and magnetic fields, there was a force that rotated this loop of wire, and this converted the electrical energy to mechanical energy. Now I'm going to draw a generator, which is very similar, and I'll explain how that's different. Okay, now here's my diagram of a generator. You'll notice it's almost the exact same thing, just very slightly different. In this case, instead of starting off with electrical energy, I'm starting off with mechanical energy, so I had to apply a rotation to this generator, and that causes the physical motion of this loop to rotate through this magnetic field. The change in the magnetic field as a result of that will induce an electric field, and this creates a current in the loop which can be harnessed on the other side of this diagram. Okay, so both generators and motors operate very similarly, but they have the opposite functions. In the case of the generator, it starts off with mechanical, converts to electric energy, and then in the case of a motor, it starts with electric energy and converts it to mechanical. The way it does it is pretty much the same. It's just through induction. These changing fields induce each other. So with a changing magnetic field, we can create an electric field which induces a current for the generator. For the motor, the electric field from the current already running through the wire, going through that magnetic field, results in a force acting on that loop, which rotates and then creates mechanical energy. Okay, that's going to be all for today's video, and we're going to wrap up this unit now on electricity and magnetism. But the next unit is going to be very closely related. We're going to be talking about currents and circuits more specifically. Okay, so thank you guys. See you next time.